September 6, 2019 was the day on which Vikram lander performed an unsuccessful landing, which resulted in hopes were shattered, hearts were broken, but we all knew this wasn't the end. This was the start of something else, and today we know that this was the beginning of the Chandrayaan 3. With same list of mission objectives, the Chandrayaan 3 is expected to lift off on 13th July 2023, and the mission objectives and the payload, basically the experiments which are to be conducted on the lunar surface, are same as that of the Chandrayaan 2 mission. Initially, there were some reports that JAXA and ISRO, which is the Japanese space agency, will collab for Chandrayaan 3. These reports are right, but now the news is that they will collab for Chandrayaan 4. But why? Because these reports were published before the crash of Chandrayaan 2, which completely changed the scenario and the mission objectives of Chandrayaan 3. Originally, Chandrayaan 4 was Chandrayaan 3, but due to the crash, it changed the mission objectives. So now let's have a look at them. The main objective of this mission is to demonstrate a safe and soft landing on the lunar surface and then conduct some crucial experiments with 7 different payloads. The payloads are divided into 3 sections: rover payloads, lander payloads and propulsion module payloads. All 3 sections contain critical instruments, and these instruments will inspect the moon's atmosphere and lithosphere. So now we will be finally diving into the details. When it comes to rover payloads, things starts to get interesting here, believe me. LIBS and APEX both analyzes the light emitted from the lunar surface, but there is a catch. The lunar surface does not emit any light, it only reflects the light which came from the sun. Then how is it possible? How can it work? Well, spectroscopy is a rapid chemical analysis technology that uses a short laser pulse to create a microplasma on the sample surface. The emitted light from the plasma is then collected and coupled for LIBS spectral analysis. So that's the whole chemical process, and that's how we get to know that what's in the soil of the moon, what elements does it compose and how it is made up from the stardust. Each element in the periodic table is associated with unique and different LIBS spectral peak. By identifying these different peaks for analyzed samples, its chemical composition can be rapidly and correctly determined. APEX, which stands for Alpha Particle and X-ray Spectrometer, is an instrument which was also used by NASA's Mars rovers Opportunity and Spirit. APEX determines the elemental chemistry of rocks and soils using alpha particles and X-rays. What happens here is, the alpha rays are emitted and bounce back from a science target into the detector, which is placed in the apex, along with some X-rays that are excited from the target. In the process, the energy distribution of alpha rays and X-rays are measured by the detectors and then analyzed to determine the elemental composition of the target.
Unlike Chandrayaan 2, this time the orbiter or propulsion module payload will also be carrying out an experiment. This experiment is called SHAPE, which stands for Spectro-polarimetry of Habitable Planet Earth. This experiment aims to use Earth as a reference for future studies of exoplanets. Polarimetry is used in the study of planets by measuring the polarization of light either reflected or emitted by these planets. The basic principle behind it involves splitting the incoming light into different wavelength components and measuring their polarization states. Studying this, we can gain insights into various aspects of planets' composition, structure, and atmospheric conditions. The lander, on the other hand, has a variety of exciting equipments. First of all, we have ILSA, which will measure the seismicity around the landing site and represent the structure of lunar crust and mantle. Next up, we have CHEST, a scientific experiment that studies thermal properties of the lunar surface. Specifically, it measures the temperature of the moon's regolith. As the name suggests, this experiment is named after Dr. Subramanian Chandrasekhar. LRA is an instrument consisting of corner cube reflectors designed to reflect laser beams back to their source. It can be used to measure the distance between Earth and Moon accurately, which will also help us to explore lunar interior.
Last but not the least, we have RAMA, which is a scientific experiment that studies the ionosphere and atmosphere of the moon using radio waves. It uses a radio telescope to observe the radio waves emitted by different layers of the moon's atmosphere and ionosphere. The goal of Ramha is to better understand the physical and chemical processes that occur in these layers of the moon. The conclusion of the video is that this mission, the Chandrayaan 3, has to succeed in order to lay path for its successors, which will be Chandrayaan 4 and Chandrayaan 5, if they are planned to take place in future. And if this mission succeeds, which it will, not only India will be proud of ISRO, but the whole world will also acknowledge the fact again that space exploration can be done. It can take place successfully with a minimalistic budget like ISRO is known to do. With that being said, thank you for watching, and we'll discuss the future of ISRO after the Chandrayaan 3 mission and the directions they will probably head in. So with that being said again, thank you for watching and best of luck ISRO for Chandrayaan 3. Let's go.